My name is Paul Langdon. I'm a cloud architect here at a connected device company in Avon, Connecticut. I'm also part of Intel's Innovator program with a focus on IoT. And I'm here to talk about some concepts that play into computing and AI at the edge. So let me share out my slides here. So my presentation is Life at the Edge. A quick abstract. The Internet of Things is evolving with a very large number of things, collecting and sharing data. An estimated 50 billion devices by 2020. If you had a chance to catch Brian's presentation this morning, you know that this is going to bring some really big challenges, some of which that involved networking, but also how things get processed in a timely fashion. If you're relying on network constraints and you need to process data quickly, that's not necessarily a good scenario. There's going to be large amounts of data passing across the cloud, and this is going to reduce to further and further congestion. And then the security of this data moving across networks is, I think, a pretty big concern. There's a handful of architectural patterns that we're going to talk about, some of which including fog and edge computing, which seem to want to localize data closer to the sensor and move them away from the centralized cloud. And if you want to have kind of like a more philosophical view into that or further justification, there's a great paper that came out a couple months ago called Edge Fog Cloud by a couple PhDs out of the Department of Computer Science over in Helsinki. So the link's there. It's also in my slide deck in the references. It's a pretty good read, but I'm not going to go into that too much here. Okay. To bring everybody up to speed, just a quick glossary of terms. Some of the things we're talking about, we mentioned edge and fog already, but cloud computing, it's been around for quite a long time, at least in concept, and then kind of came into realization in the 2000s-ish, but really drove the boom of what we know as IT today. Without infrastructure costs, or with existing infrastructure costs for being able to spin up a business, it wouldn't be possible. And with kind of the advent of AWS and Microsoft and Azure clouds in recent time, it really has, I think, catapulted things. The edge computing, kind of this methodology of doing or performing data processing at the edge. This reduces bandwidth and keeps data from having to go to a centralized location. And it's thought to be a short 1 or 2 hops from the actual sensor data, sometimes referred to as mesh or peer-to-peer. And then this kind of new concept introduced by Cisco not too long ago, fog computing. And this refers to the layer that sits on top of these edge computing devices. They could be network switches, they could be the infrastructure that sits right above that. Okay, and another kind of key driver in this edge computing paradigm shift is just some of the compute power that's available at the edge. Just several years ago when the Raspberry Pi came out, the Pi 3 now, which is now about a year old, is about 10 times the processing power that you had of the Pi 1, able to do about 6 billion operations per second. I mean, that's a lot of compute power, and if you're building these edge devices or gateways with this type of technology, there's quite a bit of compute at that side. So there's a lot of opportunity to leverage this edge computing. Some of the other Edison and Intel Joule, which is pretty racy compute module that is available to be able to run at the edge. And some other kind of key factors around why edge computing would be important. Aside from the concerns about network congestion and bandwidth, security, I think, is a huge factor. And I like to refer to it as Costners Law, which we refer to as if you build it, they will come. You talk about putting large centralized storage out on the web or out on the cloud, and there's a lot of good reason for people to kind of find that as attractive targets. So the more data you kind of aggregate out to places, the more likely you're going to have people kind of looking for it. And then privacy is another big factor. Once you start to integrate all these kind of cameras and microphones in your house, there's kind of some interesting conundrums around that. There's actually a paper that was published just last week. Even though a lot of this data is encrypted, these smart home data, there was a couple researchers that were able to profile the exact type of devices that were in someone's household, looking at the usage patterns coming out of it. So even though you may have kind of end-to-end encryption on these devices, your privacy may kind of be in question as these devices kind of proliferate across your house. And wouldn't it be nice to kind of be able to localize some of this data inside of your own fog or edge? Okay. So if you kind of subscribe to any of these theories on why we'd want to look at cloud computing or edge computing or fog, I was going to go through a couple of three patterns that can be used for edge processing for AI, whether it be computer vision or voice recognition, and also how gateways kind of play into that role. I've been kind of lucky enough to be able to dabble in some of these projects, whether it be through the Innovator program or through my professional career. And I was hoping to just walk you through some of these kind of really easy to use or easy to start up projects and give you some source code as well as some examples for how you can get started. So first I want to talk a little about computer vision. Computer vision is defined by acquiring or analyzing images, whether you're doing object or face recognition. And then there is a lot of training or learning models built into that. There are a handful of cloud-based solutions for this. So this is a edge solution that would look to kind of compete with either Google's TensorFlow or IBM, Azure, AWS's recognition, and then there's another cool company out there that I've liked to play with, which is called Clarify. These services all offer free tiers, but once you start to want to roll this out of production, things get very expensive. I mean, it doesn't seem like 0.02 cents per image is a lot, but once you start to do video or want to really roll this out into a commercial application, it can get to be really expensive. These edge-based options, the one that I've been using is OpenCD. It's a great project. It's pretty mature. They're on version 3. It's a C-based library, and it does have bindings for Python as well as JavaScript. I've been able to successfully get it to run very well on Edison, Joule, and Raspberry Pi. It has built-in training learning models, and it supports both stills and videos. And here's a kind of couple pictures of it in action doing both face recognition. It can do gender recognition as well, depending on training, but it also works for other types of objects beyond faces. Like I said, there are some really great build your own projects out there, specifically if you want to look at how you do training. There's an article here. It's a couple years old, but it's a really great getting started article on how to build your own classifier. And then here's a really easy to set up Node.js version of it. And I was going to jump over to a live demo where I implemented this Node.js model here running on a Intel Joule. So I'm going to switch over to a camera. So bear with me for a second here while I try to do that. So there's me again. So I'm going to come over here and spin up my Intel Joule here hooked up with a camera. And I'm going to, okay. So I've got a small web camera here hooked up to a Joule. Oops, I pointed right at it, right there. But what it's doing is running a face recognition algorithm in real time in real video. You can see it's trying to draw a box around my face. It really doesn't like my wallpaper very much. It looks a lot like faces, but you can see the little images here that it's trying to recognize as faces. It's pretty easy to hide from. Look, I'm not there. Oh, there I am. Oh. And this is entirely written in Node.js calling these Python bindings. So let me jump right back to my slideshow. So what I did was I went out modeling it after this Node.js for OpenCD package. I was able to build this application relatively quickly, deploy it on an Intel Joule. I was able to deploy it also on an Edison and a Raspberry Pi. So quick way to kind of get started with face recognition. So the next kind of open source or fun to play with um, AI application is voice recognition. So you can obviously think of Alexa and Google Home. And this is acquiring audio files, converting it to something that can be processed for speech to text, and then doing actual intent processing. And there is also some learning models around there. Kind of common libraries used out there out in the cloud. Amazon Alexa, obviously, most popular. Google's voice assistant. Azure has a voice to text, as well as IBM Bluemix. Again, if you're kind of a hobbyist, the free tiers are good for up to a few minutes to about an hour worth of real translation. But after that, you get to pricing models that are 0.04 cents per request. Again, if you had to pay that every time you wanted to turn on some lights in your house or ask how much an elephant weighs, it can get pretty expensive. So there are some really interesting open source models out there. There is one open source project called Mycroft. Not only do they have a Kickstarter for some actual hardware, they have a really cool open source project for building your own. Again, it's very easy to run this or get this up, spin this up and running on a Edison as well as a Joule or a Raspberry Pi. And they have their own JSON-based modeling language. The project's up here at app.mycroft.ai. It really is a pretty well documented and pretty well implementable library. There's a couple other options out there. CMU Sinks is another one written in Java as well as C if those are more your languages of choice. And those also will run on most Linux-based applications, whether it be a Joule, Edison, or a Raspberry Pi. And it has some built-in training libraries as well. Okay, and there are a handful of kind of hybrid-based solutions. If you've had a chance to play with the Google Voice API, actually, I'm going to go to this next slide. You may recognize this box here. It shipped out with a magazine about a month ago. If you were lucky enough to get your hands on one of those, this is what I call a hybrid solution. You have the ability to process voice commands locally without having to send them all to the web or out to the cloud. If you can go take a look at the project out there. It's AIY projects with Google /voice, and you can attach your own actions right in the Python code where you add actors, and this is as easy as putting your own keywords in there. So turn on my lights, and you can process local functions there. So whether you wanted to kind of short circuit the call up to Google's cloud to use their smart home API, you can use it to drive any local function that you can call from Python, whether you want to drop something on an MQ, whether you want to fire off some local GPIO. It's pretty nice to be able to localize that traffic without having to send that up to the cloud. Okay. And then the next thing I want to talk about, or the last thing I want to talk about, was something called gateways. What is a gateway? Kind of in the ecosystem of IoT, a gateway is really an intermediary between your sensors and the cloud. In using like a Raspberry Pi or a Edison or a Joule at this gateway function, you can inject a lot of these edge processing technologies right there at that gateway level, whether you want to aggregate data or do some kind of processing. And kind of a pet project of mine that I've been working on, where we are taking sensor data from a greenhouse. What we were finding is that we were moving huge amounts of data up to the cloud for processing when we were sampling data for plants, which you don't think of something that changes very often. What we found is we were able to add a type of aggregation algorithm down at the gateway so that we were managing the frequency and the change state. However, in that type of scenario, when something goes bad, you obviously want to know about it very quickly. But when things are pretty static or constant, you're not necessarily wanting to have to push all that data up to the cloud. So being able to have that additional layer of analytics closer to that sensor layer, you are able to leverage some efficiencies, both with the amount of data you're moving over the cloud, especially when you're in a greenhouse type scenario where you have you may not have excellent connectivity, or you may want to be aggregating data and pushing it up on a schedule based. And then kind of a deeper look into what this gateway stack looks like. A lot of these gateways may be aggregating different types of network connectivity. Say, for example, a lot of our sensors use just Bluetooth. We don't necessarily want to, or we're not going to necessarily be able to use Bluetooth to talk up to the cloud. So we're aggregating some of these sensors, some of the sensor data right at this gateway, converting that data into the appropriate data structure, and then moving it up to the cloud via MQTT. And another added functionality of this kind of gateway approach is that you're able to layer security on top of this, whether it be not able to implement robust security stacks at the sensor level because they usually have relatively low compute. You have the ability to add this this security level on top. And then also whether you want to add some additional layer of manageability, which I was mentioning before, where you aggregate or manage your farm of sensors without having to go all the way up to the cloud. So if there's like a project that if you're looking to kind of explore this gateway, there is a really cool article I came across a couple weeks ago up on an Intel site. There's a whole IoT track, and there's there's two nice path to production tutorials. They're a really nice exploration into how you would deploy a solution all the way from ideation to actual implementation. They allow you to get all the source code. They describe the project in depth, from somebody ideating around how they're going to build a smart home product down to what kind of sensors they want to look at, a garage door, they want to look at the doorbell, and then the full map of building a prototype with a Grove kit in an Intel NUC, and then eventually rolling it out to production grade sensors and a production grade gateway. The code, like I said, is all up there in a GitHub account for both the prototype that you can build if you happen to have a NUC or an older laptop or something that I was able to build it on, and then a Grove kit lying around. You can build the prototype and then see the process from there. They have, using the XDK software bundle, you're able to grab the source code to be able to build both a mobile and a web-based app. It's a pretty nice project. They also have one out there for building a smart vending machine. Again, it's a full ideation to implementation exploration. Sorry, I didn't realize I could be looking over here at these questions as they were coming through. Okay, so that's all up there in GitHub. And then I've got a couple different resources here. Like I said, I've kind of have an interesting kind of career and hobby path that I'm able to play with a lot of these solutions. And I've across these 3 different platforms, published most, if not all, of these projects. So if you wanted to go look at how to do the source code for using OpenCD or implementing it in your project, or these voice controls, these projects exist out there in the cloud on some of these resource sites. Okay, I realized I went really fast through my slides, and here I am at this question phase. What kind of board did you use for the greenhouse project? The greenhouse project is almost on its 5th iteration. Originally, I prototyped the project with Arduinos and Raspberry Pis. It evolved into using some Intel Edisons. At the moment, I've moved back to some ESP boards, ESP8266 boards, and Raspberry Pi as a gateway. Please do discuss about battery consumption in case of processing at the edge compared to uploading the data for processing. What's the best way to tackle that? So battery consumption can kind of be handled in a couple different ways. I know kind of from professional experience, some kind of a nice pattern or model that I know works with using sensors at the edge is a sensor that only wakes up and pushes data out, let's say every 6 to 8 hours, without necessarily having to have a live kind of Wi-Fi connection or Wi-Fi stack. So every 6 or 8 hours, it wakes up, pushes a data point to your gateway, this intermediary, whether it be some kind of Linux gateway that can aggregate that data, but also has the ability to kind of keep in check when the device was last checked in. So let's say, for example, you've got a sensor out in the field, and every 8 hours it wakes up and pushes up either an I'm okay or there's a problem. After 12 hours, if that device hasn't checked in, then you may want to push that alert to your end user that not only is are things not okay, but you've necessarily lost your processing. So that's kind of a good use of how you'd limit battery consumption by kind of having this centralized gateway in the middle. Presumably that would be a powered device, and you would be able to keep the battery pieces or the batteries for your sensor stack. How reliable are ESP boards when considered in building a product around it? I don't know if I would go to production with an ESP board per se. I think there are other options or other stacks, although some of the production boards that I've used are nearly not as stable as the ESP boards I've seen. But I guess certainly at the kind of prototyping or ideation phase, it's definitely a neat stack to play around with. I think the newer ESP boards are gonna you'll find there's a lot more reliability in. Do you mean to activate the system when the sensor value when the sensor values above the threshold limit? Yes. So the sensor does, or these edge sensors do kind of 2 things. One, they have like a check-in health check that happens on a schedule, so that you don't necessarily have your Wi-Fi stack up and running the whole time, which is probably your most power resource heavy piece. You would trigger on events. So say, for example, if you're monitoring, pH or EC or some kind of temperature inside your greenhouse, when a threshold's crossed, you would then kind of wake up your Wi-Fi, push your alert out, and then go to sleep, or wait for kind of an alert change mode. So in that sense, yes, you would trigger on that, but you wouldn't necessarily want to have this device on Wi-Fi all the time, always polling, always checking. It's really kind of, you want it to sleep as much as you can. Any recommendations for data compression libraries from gateway to cloud? I don't. I know I'm trying to think of the library. It's been a long time since I've visited that tier via, I guess, also only sending select data, but also we do a kind of end-to-end encryption with our data. But I don't. I'm sorry, I don't have a good answer for that. Wi-Fi. Why not A2.15.4 base protocol? Um, I don't have a good answer for that. What do you think about EdgeX Foundry? Oops. The open source project hosted by Linux Foundation. I think I need to look more into it. I don't know much about it. Is it more power efficient? Oh wait, it is. Oh, it's much more power efficient. Okay. What should be considered for alternatives to ESP having similar functionality for building a product? There's, I guess if you were at the point where you're ready to kind of start looking at going into production, there's a couple Broadcom boards that I know folks have had good luck with. I mean, that's the only one I'm familiar with beyond the ASU boards. Deploying an AI system, what would you suggest for board processing or uploading for processing? Deploying an AI on the system, what would you suggest on board or uploading for processing? I meant deploying an AI system. I'm not sure what that meant. Oh, considering battery life. Oh, what do you mean? What would I on the gateway? I guess I'm not sure I'm following you. Deploying the AI system, what would you suggest on board processing or uploading processing? I guess I wouldn't necessarily look to do any of these kind of gateway processes on anything that would be battery based. I know that may not be necessarily an option in every scenario, but I think with kind of that, the intent of a gateway is that there is some sort of kind of always on. What would be considered an alternative to an ESP for having similar functionality for building a product? Upload always. I don't know. I'm not sure what you mean, and if the answer is, or the question is the alternative to using an ESP to always upload it or to pass it to the gateway? I mean, the point where I was kind of getting at is that in a gateway type model, you have the ability to kind of push that data to the intermediary, and if it's not a critical state, you have the ability to maybe cache or aggregate that data before you push it up to the cloud. You wouldn't necessarily have to flush it up all the time. So you could kind of take advantage of some of the schedule saving there by necessarily not pushing it up all the time. I've got the reference here as well if you want to pull down my slide deck for some of those other articles with the links. But again, if you have any interest in looking at some of these projects fleshed out, I've got them all up at these kind of respective sources. I don't know how helpful it's been, but I tried. Thank you. Have a good afternoon. Enjoy the rest of the presentations.